Okay, here we are at Titan Machine Tool today. Going to show you what we got going on. We're making some retaining rings made out of mild steel, cold rolled boss stock. 1 5/8 OD, plus nothing minus 1. We have 2 overlapping diameters. We have a diameter here, and we have a diameter here that overlap and intersect at these points. And at those intersecting points, we have a 1/8 radius. So the big diameter is 1'50". The smaller diameter is 880. 2 different center lines for the radii. And at the intersecting points, we have 1/8 Conrads or blends between the two to soften that intersection between these 2 diameters overlapping. Drawing calls for 128 through holes, so I'm guessing those are clearance for 540s. But I drill them tight. I like tight holes for fixturing. So even though the drawing calls for 128, I ream those 124 because I'm going to fixture these down to deburr that inside feature after I have individual pieces. And that way, if I use 540 screws, the body diameter on the screw is like 122, 123. I ream these holes 124, keep the holes tight. I like tight holes for fixturing. And then when we put the bodies of the 540 screws in there, it's going to line this thing up good enough to just go back in and deburr. We're going to run a 45 tool, chamfering tool around there just to clean those edges up right there. So how I did these, I started with a piece of bar stock, turned it 1.625 round, plus nothing minus 1, big enough to be able to hold on to it and have more than enough material to cut off the rings. I need 4 rings, they're 100 thousandths each, so you need at least 1/2 inch of material plus whatever you're cutting them off with. So I started off with this, turned that in the lathe, brought it over to the milling machine. Came over to the milling machine, set it up in my Taft Pierce V-block right there, just like that. Put that big slug in there, clamp that guy tight, and then I machined that inside profile of those 2 overlapping radii. I drilled my 128 holes. This is a bad representation. It was more like this. So I cut through that big old piece. I cut that 1 inch deep, that profile for those rings. And then after that was in there in the holes, I took it back over to the lathe, put it in the chuck, trued it up, and then used my Iscar dew grip cutoff tool. So then while they were in the lathe, accounting for the thickness of the tool and the 100 thousandths finished dimension on these parts right here, I go in, face the material so it's nice and square, put my cutoff tool in, boom, part 1 off. Go back in, put my facing tool back in, reface the part so I get a nice square clean edge. Put the cutoff in, choop, part off another one. Rinse and repeat. Face, part them off. Reface, cut to clean, part them off. Obviously I part them off thick, bigger than I need them. And then I take my extended nose emergency 5C collet here, and I bored a 1.625 diameter, 80 thousandths deep. So I can take these guys, put them in, boop, face side 2. So then I brought them in 100 thousandths, maybe 6 or 7 thousandths oversized or whatever. Then I put them on the surface grinder and I ground both sides flat, so they look nice too. Surface finish on cold rolled steel, blech, yuck. So we make it look really nice and shiny, make it look sexy. That way they're nice and flat too. They sit flat. Thickness wise, they're all nice, consistent. So that's how I made those babies. This extended nose collet right here. What do we got? This is what I had. SPI. SPI is not terrible. I try to not buy Chinese products. I like the food, but I don't want to support the enemy by buying their product. I'll take hardened collets all day long. I'll take Lindex collets all day long. I try to avoid the Chinese products. I don't want to support the enemy, if you know what I mean. USA, American manufacturing all the way. So now we're at the point here we're going to deburr these things. So that's why I like keeping the holes tight. I drill and tap the bolt pattern into this aluminum plate right here so I can screw these rings down to it after I've done all the other operations. The only thing left is to deburr that inside feature. I don't want to file it. I don't want to use a little hand deburring wheel. I want to cut an angle on there. Just a subtle one. Very subtle. You might see the edge a little bit there. What I do is I put each one of them on, and because I'm locating with the bodies of these 540 screws, they're not going to be perfectly consistent. So I back the tool off a little bit. I run the profile at what would be Z0. See if it touches on one side or the other side or up top or down. And if it doesn't look to be perfectly on center, if it's cutting heavy on one side, I'll adjust the center line a little bit, 1/1000th this way, 1/1000th that way, just so that it visually looks equal all the way around when the tool runs around it. So that's what you might be seeing there. If you see a little edge already on that profile, that's because that's what I did. I backed my Z off, I brought the tool down to what would be Z0, I ran around the part, see where it touched, looked like it was touching pretty equal all the way around, good enough for a deburring chamfer. If it looked like it was heavy on one side, I changed the offset a little bit to adjust the zero this way or that way, just to compensate for visuals. So it looks good, looks like we're on center now, so we're gonna run the tool, spindle on, begin the program, stop. Tool's gonna wrap into position. All right, tool's in position, coming down. Z0 right there. I'm not running in 3-axis, I'm just doing it manually. So I'll zoom in so you can see, and now we're gonna run the tool around that profile right there, just to deburr the edge. It's probably like 4/1000ths, 5/1000ths maybe. Certainly gonna look cleaner and more uniform than if I tried to do it with a file or even a little round Beartex deburring wheel. Appearance is important with me. Not only do my pots have to work, they need to look good too. If they don't look good, I'll throw them away and start again. All right, so that's done. I put a position, drill position at the end of the program just so that the thing gets out of the way. Then I can go in. There we go. I don't know if we're out of focus here. Let's see. You can see that little chamfer all around the edge right there. There we go. So that's done. I'll Scotch Brite them, and they are done. Titan Machine Tool signing off. Azita Zane.